CSIS 2470 is filmed before a live studio audience.
Hey everybody, welcome to Advanced JavaScript. Now, before we begin writing any code, it's important that we understand some of the who, what, when, where, whys, and hows of this fabulous little scripting language. So today, we'll be diving into a fascinating topic, the history of JavaScript. However, to start things off on kind of a fun note, the video you're about to watch was actually created by an AI. I know, crazy, right? Now, just for the record, I didn't use any AI to make the lecture videos that you'll be watching throughout the semester. You'll still be getting the full Stone Cold Professor experience. Don't worry. But I thought this would be a fun way to dive into our very first topic, the history of JavaScript. So sit back, relax, and enjoy some AI magic.
In 1995, the internet was a nascent phenomenon, a digital frontier that was just beginning to be explored by the masses. During this time, Netscape Navigator reigned supreme as the web browser of choice, becoming a gateway to the World Wide Web for millions of users. The web, however, was largely static, lacking the dynamism and interactivity that define it today. Web pages were simple, often just text and images, with little to no user interaction. Netscape recognized the urgent need for a scripting language, something that could bring web pages to life and enhance the user experience. They envisioned a future where web pages were not just static documents but interactive applications. Enter Brendan Eich, a talented programmer tasked with creating this language within a remarkably tight time frame. Eich was given just 10 days to come up with a solution that would meet Netscape's ambitious goals. Eich's initial assignment was to embed the Scheme programming language directly into the browser. Scheme, a dialect of Lisp, was known for its simplicity and elegance, but it was not widely known outside academic circles. However, this approach proved impractical due to time constraints and the desire for a language that would appeal to a wider audience, particularly web designers who were more familiar with HTML and less with complex programming languages. Netscape envisioned a language that was easy to learn and use, complementing the existing HTML structure of web pages. They wanted something that could be quickly picked up by designers and developers alike, enabling them to add interactivity without a steep learning curve. The goal was to empower developers to create dynamic content, handle user interactions, and build more engaging web experiences. This meant the language had to be lightweight, flexible, and capable of running directly in the browser. This need for a lightweight, embeddable scripting language led Eich down a different path. He began to consider other influences and inspirations that could help him craft the perfect solution. He set out to create a language that was inspired by Scheme and Self, incorporating their object-oriented principles, while also drawing inspiration from the syntax of Java, which was rapidly gaining popularity at the time. Java's syntax was familiar to many developers, making it an ideal model. The result was a language that was both familiar and novel, blending concepts from different programming paradigms into a unique entity. This new language, which would eventually be known as JavaScript, was designed to be easy to use yet powerful enough to handle complex tasks. It was clear that this new language had the potential to revolutionize web development, providing developers with the tools they needed to create truly interactive and dynamic web experiences. JavaScript allowed for real-time updates, user input handling, and much more, transforming the web into a more vibrant and engaging platform. Little did anyone know at the time, however, just how impactful this creation would become, shaping the future of the web and extending its reach far beyond its initial conception. JavaScript would go on to become one of the most important and widely used programming languages in the world, a testament to the vision and ingenuity of its creators. Before it became known as JavaScript, the language went through a series of name changes that reflect its evolution and the marketing considerations of its time. Initially, the language was dubbed Mocha, a name that evoked images of the popular coffee drink and hinted at its intended role as a scripting language for web pages. However, the name Mocha was short-lived. As the language matured and neared its official release, it was renamed LiveScript. This new moniker better reflected the language's ability to bring web pages to life, enabling dynamic content updates and interactive elements. The name LiveScript highlighted the language's role in creating a more dynamic and engaging web experience. However, the most significant name change was yet to come. In a strategic marketing move, Netscape partnered with Sun Microsystems, the creators of the Java programming language. capitalizing on Java's growing popularity, Netscape decided to rename LiveScript to JavaScript. This decision, while primarily driven by marketing considerations, forever linked the two languages in the minds of developers. It's important to note that despite the name, JavaScript and Java are distinct languages, with significant differences in their design and purpose. JavaScript was designed as a lightweight scripting language for web browsers, while Java is a more robust, general-purpose programming language used for a wide range of applications. The name JavaScript, however, stuck, and the language quickly gained traction among web developers. Despite its initial promise and rapid adoption, JavaScript faced numerous challenges in its early years. The language, which was created in just 10 days, was initially intended to be a simple scripting language for small tasks. However, as the web grew, so did the demands placed on JavaScript, and it struggled to keep up. The language's rapid development cycle, driven by the need to keep pace with the evolving web, resulted in inconsistencies and quirks that frustrated developers. These inconsistencies often led to unpredictable behavior, making debugging a nightmare for many. Furthermore, JavaScript's loose typing system and lack of strict error handling made it prone to errors, especially for novice programmers. This lack of structure meant that even small mistakes could lead to significant issues, causing headaches for both new and experienced developers alike. Adding to these challenges was the widespread misuse of JavaScript. Developers, eager to leverage its capabilities, often used it in ways that were not intended, leading to inefficient and problematic code. Web developers, eager to embrace the language's dynamic capabilities, often employed it in ways that degraded the user experience. They added excessive animations and dynamic elements without considering the impact on performance and usability. Excessive animations, intrusive pop-up windows, and poorly designed scripts became synonymous with JavaScript, tarnishing its reputation and leading some to view it as a nuisance rather than a powerful tool. Users often found themselves frustrated with slow-loading pages and annoying pop-ups, which became a common complaint. Moreover, early web browsers lacked the performance optimizations present in modern browsers. These early browsers struggled to efficiently execute JavaScript, leading to sluggish performance and a clunky user experience. JavaScript, being an interpreted language, often resulted in slow and clunky web experiences, further contributing to its negative perception among users. The combination of slow internet speeds and inefficient code made browsing the web a frustrating experience for many. The combination of these factors led to a period where JavaScript was often seen as a necessary evil, a language that developers had to contend with but often approached with trepidation. Many developers preferred to use other languages and tools whenever possible, only resorting to JavaScript when absolutely necessary. Despite these early struggles, however, a dedicated community of developers recognized JavaScript's potential and worked tirelessly to improve the language and its ecosystem. They collaborated to address the language's shortcomings and to create tools and frameworks that would make development easier and more efficient. Their efforts would eventually lead to the standardization of JavaScript, the development of powerful libraries and frameworks, and the emergence of JavaScript as a versatile language capable of much more than just animating web pages. Today, JavaScript is a cornerstone of modern web development, powering everything from simple websites to complex web applications and even server-side programming. By the late 1990s, JavaScript's rapid evolution and the emergence of competing implementations from other browser vendors led to a pressing need for standardization. The web was growing at an unprecedented rate, and developers were eager to harness the power of JavaScript to create more dynamic and interactive web pages. However, the lack of a unified standard meant that code written for one browser often didn't work in another, causing frustration and inefficiencies. To ensure interoperability and prevent fragmentation, Netscape submitted JavaScript to ECMA International, an organization responsible for developing and maintaining standards for information and communication technologies. This move was crucial in bringing together different stakeholders, including other browser vendors, to collaborate on a common standard that would benefit the entire web development community. In 1997, the first edition of the ECMAScript standard, officially known as ECMA 262, was published. This document laid the groundwork for what would become a series of ongoing updates and improvements to the language. ensuring that it could evolve to meet the changing needs of developers and the web itself. ECMAScript provided a standardized specification for JavaScript, ensuring that different implementations of the language would behave consistently across web browsers. This was a monumental achievement, as it allowed developers to write code with the confidence that it would work across different platforms, reducing the time and effort needed to test and debug their applications. This standardization was a critical step in JavaScript's maturation, fostering greater interoperability and encouraging wider adoption. Developers could now focus on innovation and creativity, rather than worrying about compatibility issues. This led to a surge in the development of new tools, libraries, and frameworks that further enhanced the capabilities of JavaScript. The ECMAScript standard defines the core language syntax, data types, and essential objects that make up JavaScript. It serves as the blueprint for how the language should function, providing a clear and consistent set of rules that all implementations must follow. This ensures that developers have a reliable foundation upon which to build their applications. It provides a common ground for browser vendors to implement the language, ensuring that JavaScript code written for one browser would run as expected in others. This was particularly important as the web became more complex and the demand for rich interactive experiences grew. This standardization was essential for the long-term health and stability of the language, paving the way for its widespread adoption and the development of a rich ecosystem of libraries and frameworks. These tools have become indispensable for modern web development, enabling developers to create sophisticated applications with relative ease. While ECMAScript provided a solid foundation, it's important to note that browser vendors retained the flexibility to implement JavaScript in ways that best suited their respective engines. This allowed for innovation and optimization, as each vendor could tailor their implementation to leverage the unique strengths of their browser. This led to some variations in browser support for certain features, but the core language remained consistent thanks to the ECMAScript standard. Developers could rely on this consistency to build robust applications, while also taking advantage of browser-specific enhancements when needed. This standardization effort marked a turning point for JavaScript, setting the stage for its transformation from a quirky scripting language to a powerful and versatile programming language. The establishment of ECMAScript not only solidified JavaScript's place in the web development world, but also laid the foundation for its future growth and evolution, ensuring that it would remain a vital tool for developers for years to come.
Hopefully y'all enjoyed that little AI adventure. I thought it was a fun way to start things off. Anyway, we're going to dive deeper into some serious JavaScript awesomeness in the real lectures. And if you can answer the questions on your screen right now, then you're ready for the post-video quiz. But more importantly, you've learned what you needed to learn from this lecture. We'll see you next time.